All right, NET 201, LAN WAMs. This is the second day we met. We covered the first section, the first chapter in design. Okay, the students came up with some issues that have to do with design, reliability, secure, fast. Curriculum has it more broken down into details, scalability, performance, manageability, etc., etc. And you can check that in the curriculum. We started out with just a couple switches and a multi-layered switch. And we started talking about the connections. We talked about a PC, what would happen to the data as it was going to be transmitted from that PC. And the way we looked at it was we started from this PC here, and we talked about how it would be transmitted through this multi-layered switch to our edge router, and that's the internet. So that's the internet up there. And over here, come out of the internet to an edge router, to a simple network somewheres, we don't know exactly where, and end up at this server. So we use that process to talk about what things affect how fast it goes. And really we're talking about performance. So then we talked about throughput, and we talked about bandwidth. Okay? Obviously we have a certain bandwidth, so we have a certain amount of bits we can push through a cable into a device. In the device, something happens in order for the device to push it out another port. So we have latency. Some devices we may have more latency than others. So you can see in a diagram like this, there could be some latency between devices. And then of course, as it goes up to a router is going to look at the IP address, the destination IP. So it's going to strip off, decapsulate the parts that it doesn't need. It'll leave this part, look at that IP, figure out where it's going to route it, re-encapsulate it based on the protocol. It's going to send it out on a wire or in the air or however. And so that creates latency. So we talked about then, if you're trying to get networks to be efficient, you want a small diameter. You want them to go the fewest hops or through the fewest devices as you can to get somewhere. Okay? Then bandwidth, we talked about bottlenecks. For example, we said this might be, let's say, a 20 meg connection to the internet. So obviously if we have lots of traffic going there, that's going to be an issue in our throughput, even though we may have good bandwidth. Another issue we drew up over here, let's say we had 1 gig from that device to this one, and 1 gig from this device to this one, and 1 gig to the servers. Well, if we had multiple servers there and only 1 gig connection there, we have a bottleneck. So then we drew in a bunch of connections. And with Cisco, for example, you could have up to 8 connections. You can bundle them into one group. And then if they're full duplex, you know, that would be 8 times 2, so we have 16 gig, with the ability to push 16 gig. And so that's called aggregating. You take multiple ports and you aggregate it. Okay? We reviewed some addressing issues in terms of prefix bits and network. We talked about which layers these things are functioning at. I'm not going to go through that. And so then we started to get an idea of all the different things that are going to affect performance for a network. Performance in terms of reliability and speed, throughput, and so forth. Okay? Then we mentioned redundancy. So we talked about the whole idea of making the network redundant. Having multiple paths between the devices. Okay? And so we drew this extra one on there. And then we talked about spanning tree protocol, a protocol that manages the switching environment so we don't get any loops. And with the loops, you could get what they call a broadcast storm and actually slow down your network. And we talked about spanning tree during this course. And then we also talked about broadcast domains. We talked about if this switch is all on the one in the blue, if you see the blue there around the switch with the red in it there, if that one, that's a broadcast domain. So when those devices does ARPs, all the devices see it, and the router cuts off a broadcast domain. Well, we can also go into that switch and split the switch into two possible networks. So that would be a virtual LAN. And then this trunk going up to our multi-layered switch can manage keeping track of which virtual LAN the packets are from. So we can literally split up a specific piece of hardware into LANs. And we study that in this course too. Then, after looking at this, we start talking about if we have separate networks like this, then we can use access control lists to filter the IPs. We can filter an IP address and lots of other things. So we can control what packets go where. That not only helps performance, but it also enhances security. And then we also mentioned quality of service. We can do a quality of service to where we can decide which packets have priority over other packets. And a good example given in class was, let's say we have a video conference and we don't want any of those packets delayed or dropped. We can give them a priority over other packets for things such as texting or downloading something that doesn't make a difference if it's downloads in 15 minutes or 20. Okay, so we can manage quality of service. And then the last thing, there was a lot of other things we talked about, but the last thing I want to mention here, we can take all of these switches in which we're directly connecting devices to, whether they're printers or PCs or whatever. This is what we call the access layer, the layer in which we access the network. We come into the network. Okay, so you have an access layer, and then the next one up, in which we decide where information is going to move to where, whether it goes out to the internet, stays within our local network, and so forth. That often is referred to then, that would be how things get distributed. Okay, so it would be the distribution layer. Then we talked about large networks that connect all these networks from one site to another, like large companies like Walmart and Cisco and Boeing and GM, and you could go on, Exxon and so forth. We have what we call a core layer. In the core layer, we pay for, typically we have WAN providers allow us to connect our different devices, or actually our different networking devices, in order that one location, let's say in Austin, Texas, can talk to a location maybe in Seattle, Washington. So in the core layer, since we're paying for those WAN connections, we need to move the packets as fast as possible. So the only thing those core layer devices really should be doing is determining the best route and sending the packets out. We do not want them doing any of this work. This work should be done at the distribution layer before we ever send any packets to the core layer. All right. We were going to take the assessment today, but I decided to allow the students a little extra time to absorb the information. We'll take care of the assessment on Tuesday. And our next step, on Tuesday, they should have read Chapter 2 and prepared to take the pre-assessment for Chapter 2 on Tuesday. And then we'll work in Chapter 1 assessment either on their own time or later in the week in class. And that's it.